All right, so this is the Chapter 6 scenario worksheet, and I thought I would try to work through this with you. I'm not necessarily going to write everything down, but at least you can see my thought process as we work through this problem. All right, human social cues. So we know that dogs are good at perceiving our facial cues. They're domesticated companion animals, and, well, wonderful. Horses also understand human facial cues and expressions of anger, but goats were not really domesticated as companion animals. They were mostly food and milk, which is also food. So, selective breeding was used to optimize all sorts of things, but not good behavior towards humans. So, the question here is, do animals that are in close proximity to humans pick up the ability to read our facial expressions, or is this something that has to be actually selected for? So in this particular study, researchers looked at 35 goats from a goat sanctuary in the United Kingdom and tested whether goats also display any sort of preference for human faces showing positive or negative emotion. And so they set this experiment up where goats would be let into a pen, and there'd be a happy human face or an angry human face on a stick. And the paper actually says this, approximately goat height. Each of the goats was assigned to either see the happy or angry face, and during each trial, researchers recorded the amount of time in seconds each goat spent in proximity to the face. So I've left out a few things on how they trained the goats to generally approach a neutral human to get food. Anyway, these goats were trained to kind of investigate and maybe I'll get food, but not to react to any sort of human emotion. All right, so 4-minute trials. How close or how long the goat spent close to the human face on a stick. And the distribution looks something like what's shown in the figure. So, yeah. Okay, so our first question is this an experiment or an observational study? And so we look at this and we see that researchers are assigning the condition, right, happy or angry, to each of the goats. We see that they used random assignment, so that's good, which means that this is an experiment. All right, and so then we have to identify the experimental unit. That is a goat. And the explanatory variable, which is happy or angry face. All right. So, as we mentioned a little bit ago, the study does use random assignment. So, yes. And random assignment means that we can assume that there's causal behavior. Okay, so that means for this study, we can assume or we can make causal conclusions about whether happy or angry faces encourage goats to spend more time around them. Okay, so we can conclude that happy, angry faces cause more, less time spent. Okay, so again, we're making causal conclusions there. All right. So let's see if I can't get back to the file here. Sorry, I'm still learning how to use the screen recording software. Okay. So the next question is, does the study use random sampling? And what implications would that have for conclusions that could be drawn? And the answer is no. So, not sure what happened there and why my pen is suddenly black, but whatever. Okay. So they don't use random sampling because they didn't go out and find a population of goats and randomly sample the 35 goats in the study. They went to a nature animal shelter type thing, nature preserve, and found 35 goats. Okay. So because they don't have a random sample, we can't guarantee that our sample is representative of the population. And instead, we have to make an argument that they are representative before we can generalize and draw conclusions about the entire population of goats. You'd think I'd be better at managing to fit everything in, being able to zoom in and out, but evidently not. Okay. So the next question is, what's the population parameter of interest? And what's the corresponding sample statistic? So population parameter means Greek notation. We have a quantitative variable, so we're going to use mu as the letter. So let's say mu happy minus mu angry is the population parameter. And the equivalent sample statistic is x bar happy minus x bar angry. Okay. The null and alternative hypotheses. So the null hypothesis is going to be that our population parameter is 0, right? There's no difference between the two groups. So mu happy minus mu angry equals 0. Our alternative hypothesis is going to be that x bar, or sorry, not x bar. What am I doing? Okay, this is what happens when I try to copy off of the line above me. Okay, mu happy minus mu angry is greater than 0 because we want to know if they spend more time around the happy face than the angry face. All right. So you know that because, let's see if I can get back here. The goal was to test whether goats display a preference for human faces, showing positive emotion. So, happy greater than angry is what that means in math. Okay? All right. The next question asks you to use the multiple means applet to conduct 1,000 simulations, and you will need to open the file, and it's, I think, linked here, and paste it into the applet, and then compute your sample statistic according to the applet. So I've gone to the Rossmann-Chance multiple means applet. I also brought up the data for the goat experiment here, and I'm going to paste that into the applet and say use data. The problem asks us to conduct 1,000 simulations. Our hypothesized difference is 0. Our sample statistic is negative 16.791. And that's because it's decided that mu1 is angry, mu2 is happy, which is annoying, but whatever. So we'll just go with it. Less than our observed difference. And we shuffle our responses. All right. So this has been the applet portion of this video. Okay. According to the applet, the sample statistic is negative 16.791. And one simulation for us represents a set of 35 observations. Of goat time in proximity to a face. All right. So I'm going to go ahead and correct the sample statistic here just because it'll match the key better that way. In reality, as long as you set it up correctly and your statistic matches what you set up, the sign doesn't really matter. Okay. The distribution of simulated statistics is centered at 0. It's symmetric, bell-shaped. And most of the points are between negative 20 and 20. All right. The simulation p-value that I got was p equals 0.0260. And that is because we had 26 out of 1,000 simulations as or more extreme than 16.791. Okay. Now, to conduct a simulation confidence interval for the amount of extra time goats spend around a happy human face, we're going to say that x bar h minus x bar a equals 16.791 from the applet. Standard deviation is 8.147, but you probably got a different answer. Then we have statistic plus or minus 2 times standard error of the statistic, which is that standard deviation, right? Which means that our interval is 16.791 plus or minus 2 times 8.147, which works out to 0.497, 33.085. All right, so that's the construction. The interpretation is that we are 95% confident that goats spend between 0.497 and 33.085 seconds longer around a picture of a happy human face than an angry human face, and suggests that goats can actually read human social cues. Okay. All right. The next question asks what the validity conditions are for theory-based inference for this type of data. Are they met, and why or why not? And so it says the validity conditions are that both groups have a symmetric distribution, or 20 observations plus not too skewed for each group. Okay. The box plots that were shown on the first page seem to be pretty symmetric, which suggests that this is what applies to this problem. Which is good because we don't actually have 20 observations in each group. Okay. Assuming that the validity conditions are met, we need to calculate the standard error of the difference in the sample means, which means that we're going to start out with the standard deviation squared of happy over n happy plus standard deviation squared of angry over n angry So 23.876 squared over 17 plus 23.071 squared over 18, which is the square root of 63.103, which is 7.944. All right. And using that, we need to calculate a t-statistic and conduct a test of the null hypothesis that the two groups are equal. Our formula is t equals x bar h minus x bar a minus hypothesized value over the standard error of x bar h minus x bar a. All right, so we're going to take our difference, which is 16.791, divided by the standard error that we calculated, which is 7.944. And that works out to 2.114, which is bigger than 2. So we're going to reject our null hypothesis. And so our interpretation would be that with a standardized statistic of 2.114, we have strong evidence against the null hypothesis that goats spend equal amounts of time around happy and angry human faces, and thus cannot read human social cues. Therefore, we reject the null hypothesis and conclude that goats spend significantly more time around happy human faces than angry human faces, which suggests that goats can in fact read social cues. I'm not going to write all that out.